Welcome back. This is Joel, and in this video, we'll actually be continuing our discussion on MPLS. We will actually look into MPLS in a service provider, environment, right? It's going to be a short video before we actually jump into the MPLS VPNs. I just wanted to set the context around how MPLS is actually used in a service provider environment, right? Now you see, this is my topology, a very basic topology to explain this, the idea behind this lecture here is that we just pick this one. What I'll do is I'm going to create a very simple service provider network here, right? So that would include probably my network of routers R1, R2, R3, and probably R4 as well, right? And I would like to call this as the core network, right? Probably an AS of 1000. Okay, great. Now the other piece which I want to do here is that I will probably also go and select, give me 1 second, right? So what I'll also do is I'll probably also create a couple of other ASs here, which is let's call this AS 700 and another AS over here which is AS 500, right? Now we have learned from our earlier discussions that if you want to talk between the AS over here, then you gotta use EBGP, right? It's a similar case here as well. You gotta use EBGP because you have two different ASs. Here's AS 1000, here it is AS 500. Now if you want to talk inside the AS, right, you want to route inside the AS, you can use IBGP, right? So we have learned that as well. So inside the AS we're going to use IBGP. Also remember that from our previous discussion we already have MPLS enabled on these routers, right? R1, R2, R3, R4. Right, with that in mind, let's start configuring some of these things which we just now discussed. Okay, so I have my network here, right? So once I have my network here, what I'll do is let's start by configuring on R7 probably. Yeah, let's do this one. Let's do between R7 and R1 the EBGP, right? So I go into R7 and let's clear the screen. Let's go here. Let's do show IP, my bad, interface brief, and let's also see show IP route. What do we have connected, right? These are the routes. Cool. So what I'm gonna do is I'm gonna configure, let's do this, configure, okay, router BGP, it's gonna be 700, right? What else? The network command, right? The network command, which means I need to advertise my networks, 7 network, and I also want to do the 77 network, right? But for the 77 network I will have to give the mask uh, 0 with the mask because the mask defined is 24, so I need to clearly match that in my BGP statement as well. Done. Now the neighbor command, pretty simple. The neighbor command is 192.1.17.1 if I'm not wrong. Yep. And we have the remote AS which is going to be 100 or 1000. Okay, that looks good. So we are done here. Something I noticed here is that this interface is in shutdown state, so let me do a no shut here. With that we are done on R7. So let's go to R1 now, right? So on this one what we'll do is we will have to configure again EBGP, right? So we do EBGP and the AS is 1000 from the diagram, right? The network is one network, just gonna advertise this one network. The neighbor command is 192.1.17.1, sorry, 17.7, right, because it is R7, and the remote AS is basically clearly 700, right? There you go. So now once I did this, the BGP actually should come up between R1 and R7. You can see it has come up. Now let's do the same exercise between the other two routers, which is my R4 and R5 as well, right? So I go to R5, right? Let's do show IP interface brief and also do show IP route connected, right? And when I configure router BGP 500, the network which I want to advertise is the 5 network, The other one is the 55, sorry, dot 0, and the mask is 255, sorry, right, and the neighbor command is clearly for what? The neighbor command is going to be the R4, which is 192.1.45.4, right? That's the link between 4 and 5, and the mask, sorry, not mask, remote AS, right? Remote AS is going to be clearly 1000. Hope this is good, right? So here also I see that my interface is in, so I'm going to do a no shut here. Also I think there's an issue with this interface. I've configured with the wrong IP address, so let me do that as well. IP address is, sorry, since it is 192.1.56.5 it is supposed to be. Okay, great, no issues. I'm going to use that interface, but I just wanted to correct this because like two interfaces with the same IP. Great, so we're done it on R5. The last one is on R4. Let's do the EBGP part on R4, which is gonna be router BGP 1000 because it is in AS 1000. Sorry, that's a mistake. It's not 10,000. It's supposed to be 1000. Right, there you go. And the network command is gonna be for 4 dot, right, and the other one is the neighbor command, which is towards R5 92.145.5, and the remote AS, sorry, remote AS is gonna be what, 500. Okay, that looks good, which means we have done what we set out to do. We have done the EBGP on both the sides. Now we need to do the IBGP, right? If you want to verify your EBGP is working, what you gotta do is just do a you can just do show IP route BGP, and there you go, you get the BGP routes, the 5 routes from R4, right? Similarly on R1, if you want to do show IP route BGP, you should get the 7 routes, right? There you go. So the EBGP is like working fine. Now we need to concentrate on the IBGP, right? Now the IBGP is in my core, right? Now if you remember, how do we actually configure IBGP? IBGP, you gotta configure in a mesh kind of a network, right? You have to have every single router forming IBGP neighborships with every other router. That is how you normally configure IBGP. Now, and that's the reason why we even introduced route reflector to reduce the number of BGP neighborships. But in this example, what I'm going to do is I'm going to do something different. I'm going to establish IBGP only between 2 routers in the entire core. So which are those routers? So if I probably go here, give me a second, right? So if I probably, let me pick this. What I'm going to do here is I'm going to establish IBGP only between this guy and this guy, right, which is R1 and R4, right? I'm going to establish only here, right? And let's see if the whole network works by doing so, right? I'm just establishing one IBGP, right? So let's try that. So we're going to do that between R1 and R4. So let's do it from R1, which is already I'm inside the router BGP, so I gotta do just 4.4.4. Yes, I'm going to do I'm going to use the loopback for this, and I have already explained in my BGP classes why we use loopback is mainly for redundancy purposes. So even if your physical interface goes down, right, you will still have connectivity to your loopback, right? So that's why. Anyway, coming back, so we do update source, right? Because we're using the loopback, you gotta do update source, otherwise BGP will end up using some other IP address as the source address, and my BGP hellos will be dropped. Okay, and the next one is the next hop self. So this is kind of like a template you use whenever you do IBGP configuration. Next hop self, because IBGP doesn't change the next hop, you have to force it to change it, right? Cool. Now we do the same thing on R4, router BGP 1000, and let me clear the screen a bit. Right, so inside this we do neighbor 1.1.1 with the remote AS of 1000, right, neighbor 1.1.1 with the update source of loopback 0, and the other one is the next hop self command, right? Sorry, my bad. Self, okay. There you go. So that's it. We have established everything, or we have configured everything we set out to do. We did the IBGP, we did the EBGP, and the MPLS is already present in my core from the previous, from the previous configuration, right? Obviously, there is an IGP also. If I'm not wrong, I can show you the IGP. There should be IGP, which we did in the very first configuration, right? In my last video. So if I show you my whole router configuration, it's going to be right. So you have a IGP, the first IGP, because the IGP is needed for the LDP to work, right, for MPLS to work. That is going to support that, and then we configured the BGP. This BGP is both. It has it is like it has the EBGP configuration as well as the IBGP configuration as well. Anyway, right, so that was the whole configuration which we did. Now let's see some very interesting observations here. So if we do a ping from R7 to R5, do you think it will work? Right, let's check it out. So if I do a ping, let's say I wanna do a ping from R7 to R5, sorry, with the source of, there you go, it worked, right? Now it's this is fine. I mean, it has to work, you would argue, because if you do a show IP route, you would actually see that in the L3 table we have the phi network, right, and the next hop is R1, right? So the packet, when you are doing a ping from R7, right, the packet basically goes to R1, which is totally cool. But on R1, let's see on R1 what's happening, right? So if I do show IP route on R1, right, so I have the phi network, but the next hop for my phi network is 4.4.4, which is R4, right? So if you look from the diagram, the next hop for R1 is R4, right? So how is the packet actually going here, right? And if you look into R2 as well, if you look at the routing table of R2, let me show this, right? If you look into routing table of R2 or R3, you will see that you will not actually find the phi network, right? Because we don't have IBGP configured on these two guys, right? Since there is no IBGP on R2 and R3, we don't have the phi networks, the destination network on R2 and R3. So how is the ping actually working, right? So the ping is actually working because we have the MPLS configured, right? So this is how service providers use MPLS. So instead of running your IBGP from end to end, right now we have kind of reduced it to run only on the edges, whereas inside my network over here, inside the core, right, we are basically simply running MPLS, right? We are doing basically like a label lookup instead of a L3 lookup, right? So that's really fun. So now if I do a trace route, it would be more interesting. So if I do a trace route from, say, to the same thing, we did a ping earlier, but let me do a trace route, and let me kind of try to explain to you what is happening to the packet at every single junction. Right, so the trace route will take a couple of seconds to come up. So while that comes up, probably we can try to, okay, it's already coming up, or we'll try to understand what's happening, right, even before the trace route comes. So I'll try to do that manually. Give me a second, let me just reduce the size of this, right? So this is my diagram over here. So here what I'm going to do is, now let me just pick a color, and what we are doing is R7, right? So we did a ping from R7. Give me a minute, I think stylus, right? So this is my R7, and on R7 we have the packet, right? We have the packet, basically the ping packet over here, and let's forget about the data for now. I'm not interested in the data, right? What I'm interested is basically the source and the destination, right? It is going to be, obviously this is going to be, the source is going to be 7 network and the destination is the 5 network, right? That is totally fine as well. And so this is basically, I'm trying to recreate the packet at R7, right? And obviously the MAC address is going to be R7 over here, and this is going to be R1, because from the routing table of R7, the next stop for reaching the 5 network is R1. So the packet reaches R1 now. Okay. Now on R1, what is happening? So if you see, this is my R1, right? When trying to reconstruct the packet, the source and the destination will remain the same, and the data packet also will remain the same. That part doesn't change. But what changes is, if you look at so R1 has received a packet with destination of 5 network, right? So if I go to my routing table of R1, so let me show that, show IP route, you see that there is 5 network, and with the next stop of 4.4.4. So when it sees the next stop of 4.4.4, R1 will quickly look at the MPLS forwarding table. So MPLS forwarding table tells me that in order to reach the 4.0 network, I have to use a label, and the label is 19, right? So my take a different color. So my R1 will inject a label which is 19 over here, right? And the next stop is obviously, the next stop is clearly, this is going to be obviously, okay, different color. This is going to be R1 and this is going to be R2, right? But we have a label. So as a result of that, when you come to R2, what is happening is, though R2 doesn't have the route, right, 7 and 5, it doesn't matter, right? Though it doesn't have the route 7 and 5, which are the BGP routes, but because R2 doesn't have IBGP, obviously it doesn't have the routes as well. But still the packet is not dropped, because now it is not doing a L3 lookup, rather it is doing a label lookup, right? So because it has received a packet with a label of 19, what it will do is that it will do a label swap or label pop. So what it will do, we can have a look as well. So you can do show MPLS forwarding table, right? And the input label was 19, so it will do a label swap and put in label 16 now, right? So you see what happened here. So it put a label of 16, and this is going to be obviously the MAC address of R2 and going to the next stop, which is R3, right? So this is what is going to happen. The same process continues at R3, and then obviously at R3 the pop happens, right? Because R3 will have a label. Maybe we can do that as well. So at R3, you see what happens is, let's try to do that, right? This is still 7, 5, and the rest of the thing is data. But for a label of 16, let's see what is happening on R3. So do a clear screen here. R3 is not responding. Give me a second. Okay, so R3 is here. So if you do show MPLS forwarding table, you'll see that for the label 16, for the incoming label of 16, the action is pop label. So as a result here, you can see the label gets popped, right? So there is no more label now, and once the label is popped, obviously now this will be R3 and this will be R4, right? But once the label is popped, it becomes IP packet, and this IP packet obviously reaches R4, right? And R4 has the route to this PHY network because R4 and R5 they have a BGP setup, right? And that's how the packet is actually moving through the whole MPLS domain, right? So this is the reason why service providers use MPLS in the network, because now you see this whole core which they have here, right? This whole core which they have, this is BGP free, right? They don't have to run BGP end to end. They just need to run BGP only on the edges, whereas MPLS takes care of the forward, packet forwarding, right? So that's that's something which I actually wanted to show here, right? Um, like I wanted to show an example where in the service provider network how the packet actually moves. Okay. Now another thing which I also want to mention here is that probably if we try to tweak this a little, right? If we try to tweak this, when I say tweak, where do we tweak? If you go to the IBGP configuration, currently I have done IBGP configuration based on the loopback, right? The neighborship I have achieved, I have established the neighborship based on the loopback addresses. What I mean is, if I go to say IBGP, right? So if I do here, if you see here, the IBGP configuration is this one, right? These three lines are corresponding to the IBGP configuration. Now if you see, I've established the neighborship using the loopback. Now let me tell you, it is very much required here. It's not just recommended, rather it is required to do this, to establish IBGP neighborship with the loopbacks. Because if you don't do it with loopbacks, rather if you do it with the physical interfaces, what will happen is that, right, the whole MPLS, the whole MPLS falls down. Okay. Now I think it's better to show that, because only then we'll be able to understand. So what I'll do is, let me probably come here and destroy this BGP show run section redo. That's my BGP. So what I'll do is, I'll go here, let me go inside this, and let me remove these guys. This one and this one. Sorry, gotta do a no, right? There we go. I removed all the three. I need to do the same thing on R4 as well, because that is where I have established the BGP, right? So if I do show run section BGP, configurer router BGP 1000, right? I just take these three lines, I gotta make them, just put a no statement in before that to remove that, right? And this one as well. Okay, so did it work? I think it should have worked. Let me check. Did it? Yeah, so this is gone, and on the other side as well, it should have gone now. Let me just check. There you go. Yep, so I've removed them. Now what we'll do is, we'll try to establish the neighborship based on physical interfaces. All right, give me 1 second. Okay, so what we'll do is, now on R1 I'll do a neighbor relationship based on 192.1.34. so which is 34? This interface, right, between 3 and 4. I'm using the physical interface instead of the loopback. So 34.4 with the remote AS of 1000, right? Let's do the rest of the commands as well, right? Basically the remote AS is done. What else? I don't want the update source, because it will anyway use that interface, because it's a physical interface. Let me just do a next stop self, right? So I just do that. Okay, so we are done on R1. So let's see, we'll do the same thing on R4 as well. Just got to do neighbor 1.1.1. Do we have one more? Okay, remote AS is 1000. The other neighbor command. Oh, sorry, my bad. I don't want to do it based on loopback, right? Damn it. That is, gotta remove that. I want to do it based on physical interfaces, remember? Okay, so neighbor, instead of doing 1.1.1, I want to do between, it's going to be 192.1 12.1. There you go. And the other one is just change this to the next top self part. Okay, awesome. So the BGP comes up. That is totally cool. The BGP comes up, but let's see if the ping works now, right? So if you go to my R7, earlier the ping worked, right? So let's try the same thing again. Ping 5.5.5, right? With the source of 7.7.7. You see the ping is not working now. The only change what we have done is we have established the IBGP neighborship here, right, with the physical interfaces and not use the loopback interfaces. And you see the whole MPLS is not working, or the whole ping is not working. The reason is, so why is it actually happening, right? So if I probably let me just get rid of this. I don't want this. So now let's try to do the same activity again. Let's try to retrace the whole step, right? So you see, I did the same ping from R7. Let me take a different color here. So this is your R7. Yeah, this is R7, right? So this is my R7, and R7, I have my packet, right? The ping packet. Not bothered of the data. This is the source IP, that the destination is 5, and MAC is going to be R7. This is going to be MAC is R1, right? The packet has reached R1 now. Now on R1, right, the same process happens. R1 will first have a look at the destination, which is my 5. So if I look at my 5, let me just go down here. It's better to put this one here, right? So let's have a look here. What's happening is, if I do show IP route, you see, to reach my 5, the next stop has now changed. It is no more 4.4.4. It is 192.134.4. Now R1 will quickly look at its MPLS forwarding table, the LFIB, right? So when it looks at the forwarding table, it sees that for this particular 34 network, there is a label. The outgoing label is 18. So it will come and blindly put in this label over here, right? So we have the label 18 here, right? And the rest is obviously the MAC address, which is clearly R1, and this is going to be R2. Now you come to R2, right? R2, this is 5, this is 7, right? So what will R2 do? So R2 sees that it has received a label packet, and it will check its label table, which is show MPLS forwarding table. And what is the packet? It received a label of 18. So for when it is 18, you see the outgoing label is pop. So R2 itself is popping the label here, right? The label is popped, and this is R2, and the next stop is R3, right? I'm writing this next stop not blindly. I'm actually writing it from here, from the table, right? I know the topology, so that's why I'm writing it directly, but it's actually from the table, right? Not cooking it up. So you see R2 and R3 over here, and this is the IP packet. This is no more a MPLS packet, rather IP packet, right? So on R2 we have an IP packet. Now this packet is sent to R3, right? Since there is no label, right, on R3, what will happen? So when R3 receives that IP packet, it will first check the 5 network. It will first check, does its table have the 5 network, and you will be you know that we are not running IBGP on R3 because it is not the edge router. So you do show IP route, you will not find the 5 network, right? You will not find the 5 network, so you don't have it. The reason is because this is R3, it doesn't have IBGP, and the label got popped before. As a result, when the IP packet came to R3, it is no more doing a label lookup, rather it is doing a IP lookup, L3 lookup, and it doesn't have the 5 network, and as a result the packet is dropped. Right now all this problem came because we used the direct interface, right, the physical interface over here to establish the IBGP. And because we did that, right, because we used this particular interface here, right, we used this particular interface, what happened was that because this interface is directly connected to R3, the packet got popped here itself. Always remember that in MPLS the packet will get popped, right, the label will get popped when it is connected to a router which has the interface, right, which has a directly connected interface. So since this 192.134.4 network is directly connected to R3, the packet or the label gets popped, penultimate hop, right, we have discussed this, it got popped here. And that is the reason why it is required for us to run IBGP only with the loopback addresses, because if you run it with the loopback addresses on R4, the pop will always happen at R3, and if the pop happens at R3, then you know that the packet, the IP packet will come on R4, and R4 anyway has the route to 5, so the packet will move forward. But if it gets popped earlier, then R3 basically is helpless, right? R3 doesn't have the 5 route, and as a result the packet gets dropped, right? So basically what I wanted to explain in this particular video is that 2 things. One is BGP free core. I think you understood that part, right? By using MPLS in our service provider environment, we can kind of achieve the BGP free core. We don't have to run BGP end to end. The second piece is when you're running this IBGP inside the core, always make sure you run it for the loopbacks. Always make sure you run it with the loopback as the the neighbor commands have to be used on the loopbacks, right? You form the neighborships with the loopbacks, and don't do it based on the physical interfaces, right? So these are the 2 key takeaways from this video, right? So continue watching. In the next set of videos we'll actually be talking about something interesting, which is the MPLS VPNs. Thank you.